Hello students, in this session we are going to learn web security. So the bits included in this web security are first we will go through the introduction, then let's see what do you mean by secure socket layer, that is SSL. Then next is SSL session and connection. After that we are going to study SSL record protocol, chain cipher spec protocol, alert protocol and handshake protocol. So let's see these bits one by one. So nowadays most of the companies and organizations use web services for their business and other applications. So for these applications, security is the most important part. One can secure his or her website by understanding and implementing proper security measures. So this provides a secure environment in which the user of that website work comfortably with that application. So in this session, we are going to study secure socket layer. SSL is a certificate-based general purpose protocol. It has been developed by Netscape. SSL is used for managing the encryption of information that is transmitted over the internet. SSL also uses public key infrastructure. So, encryption is done by using the public key. So, this encrypted data is transmitted over the SSL connection. So nowadays, SSL is the most widely used protocol for e-commerce. So the transmission and routing of data on internet is controlled using TCP/IP protocol. So the SSL protocol executes the TCP/IP and below higher level protocols such as HTTP or IMAP. SSL allows the server to authenticate the client by showing its certificate. Here, the client is authenticated by using user ID and password. Authentication enables the client and the server to communicate securely. So there is an issuing authority which is responsible for distribution of SSL key and certificate. So on the server side, SSL makes these keys and certificates available and broadcast the same using protocol exchanges between the server and the client. SSL is also popular as transport layer security. Now, SSL is a set of protocols which are given below. So the very first protocol is record protocol. Second one is change cipher spec protocol. Next is alert protocol and the last one is handshake protocol. So let's see the first protocol in detail, that is record protocol. So it is used to ensure security and integrity to the data. Also it defines format used to transmit the data. Chain cipher spec protocol. This message is sent by both the server and the client to inform the other party that subsequent records will be protected under just negotiated cipher spec and keys. Let's see what do you mean by alert protocol. So this protocol is used to inform SSL related alerts to the communication parties. These messages are again encrypted and compressed. Right? So alert messages are also encrypted and compressed. Next is handshake protocol. So this protocol is responsible for establishing an SSL connection. So to establish the connection for the first time, it uses record protocol. First one, it uses record protocol to exchange the messages between the server and the client. So there are three protocols: handshake protocol, cipher change protocol, and alert protocol. Now let's see what are the main objectives of SSL. So the very first objective is authentication, second is data integrity, and third one is data privacy. So what is authentication? So the SSL protocol supports the authentication of the server as well as the client to each other. So for authentication, SSL uses public key cryptography. Generally, certificate is used for authentication and SSL also uses the same method. Now let's see data integrity. So whatever the data transmitted by the sender, it should be received as it is without any modification at the receiving end. Data integrity ensures that the data received is the same data sent by the sender without any modification. Data privacy. So during transmission of information between the server and client, the data should be protected from the attacker such that only authorized users can read it. So this is the prerequisite for the application data and the data related with the protocol itself, right? So the application data is the data that is sent during the session itself, and the data related with the protocol is the data used for securing traffic during negotiation, right? So application data is the data which is sent during the session, and the data related with the protocol is that which is used for securing the traffic, right? Now let's see the SSL secure socket layer protocol stack. So SSL record protocol is used to define the format for the message. It provides encryption and integrity to the data. It is also used to encapsulate data sent by the other SSL protocols, right? So it is also involved in the task associated with the SSL check data. The other three protocol, that is handshake protocol, is concerned with session management, right? It's concerned with session management. The next is cipher change spec protocol, is related to cryptographic parameter management, right? The next is alert protocol, is involved in transferring the SSL messages between the client and the server, right? Now let's see SSL session and connection. So the first step in SSL protocol is establishing the connection between the server and client. So an association between a server and a client is called as a session. So let's see what are the parameters used in communication. So the very first is session identifier, peer certificate, compression method, algorithm specification, master secret, is reusable, right? So let's see one by one. Session identifier. So the identifier is generated by the server and it is used for identifying a session with a respective client. Peer certificate. X.509 certificate is used for authentication. Compression method. So it gives the method used to compress the data. So compression of data is done before its encryption, right? So whatever the data we are going to send from client to the server, it should be sent in form of an encryption, but before encryption the compression of the data should be done. Next is algorithm specification. So it gives the encryption algorithm and the message digest or hashing algorithm used during the session. The next is master secret. So the client and the server share secret data of length 384 bits. Is resumable? So it is a flag indicating whether the session can be used to initiate the new connection. Next is the connection state used in this session, SSL session and connection. So the first state is server and client random. Second is server write max secret. Third is client write max secret. Next is server write key, client write key and sequence number. So let's see these all different connection states. Okay. So first is server and client random. What does it mean? So for each connection, both the client and server generate a random data. Right? That means before sending or while sending a message, they will generate a random number for every new connection. Next, server write max secret. It indicates the secret key used by the server for data return. Client write max secret. This indicates the secret key used by the client for data return. Next is server write key. This indicates the key used by the server for encryption and by the client for decryption. Right? Next is client write key. So this indicates the key used by the client for encryption and by the server for decryption. Last one is sequence number. So what does it mean? So server maintains sequence number separately for each message transmitted and received during the data session. Now let's see SSL record protocol. Now we have seen that there are various layers such as handshake protocol, record layer protocol, change cipher spec protocol and alert protocol. SSL uses these protocols for different purposes. So the SSL record protocol provides integrity service to the data in SSL. This protocol takes the data from the application layer and divides the data into different parts of fixed length. Right? So if the size of any individual part is not equal to the expected size of the part, then required number of padding bits are added at the end of the message. Then the data is compressed using appropriate compression algorithms or technique. After that, the MAC value is calculated for the respective part using the secret key. The secret key may be server write MAC secret key or it can be a client write MAC secret key depending on who prepares the packet. So here MAC is used for the verification of the integrity of the message. So MAC is calculated using message digest algorithms such as MD5, SHA1. Right? So the MAC is then appended to the part message followed by encrypting the packet of fixed length. Then the headers are added to the packet. The object created is called as a record. So this record is transmitted using the TCP protocol. So the header contains our protocol definition of length 1 byte, protocol version of length 2 byte and length of 2 bytes. So the length includes the length of the message part and the length of the padding bits used, right? So the detailed procedure of formation of record is given below. So first procedure is fragmentation, second is compression, third is append MAC, after that encryption, and last one is attach header. Now, what do you mean by fragmentation? Divide the message into number of parts or fragments of fixed size. If the part size is less than the requisite size, then necessary numbers of padding bits are added at the end of the message, right? The next procedure is compression. First you fragment the large message, after that compress the message part, append MAC. So MAC equal to hash function. This hash function will have secret key, message part, padding bits and sequence number, right? So append the MAC value to each part of a message. Next is encryption. Encrypt the complete part with MAC using symmetric key encryption algorithm. Next is attach header. Attach the header to the packet. Now, right? Now the record is prepared and made ready for transmission. So whatever the procedure has been defined here, the same procedure is shown in this diagram, right? So here what they have done, this is the message of large length. It is divided into fragments. It is also known as segmentation or fragmentation, right? So chunk 1, chunk 2, right? So it is divided into parts, the part 1, part 2, or you can say chunk 1, chunk 2. So the first step is segmentation or fragmentation. The second step is compression. Whatever the chunk 1 is there, compress it, right? After that append the MAC. After that append the padding bits if required, right? After that encryption, that means encrypt payload. After getting the encrypted payload, then attach a header. So this will be your SSL packet creation, right? So whatever the steps we have seen here, fragmentation, compression, appending a MAC, encryption and attach the header, then your packet gets ready to be transmitted to other receiver, right? So the SSL record protocol is used to provide confidentiality, applying encryption and integrity using MAC value to the message which is transferred within a session, right? Now let's see change cipher spec protocol. This is the simplest SSL protocol. This message is sent by both the server and the client to inform the other party that subsequent records will be protected under the just negotiated change cipher spec and keys. It consists of a single message. So the message consists of a single byte value of 1. The message is encrypted and compressed under the current cipher spec. The main objective of this protocol or this message is to cause the pending read or write state to be established as a current read or write state. So the client sends a chain cipher spec message followed by the key exchange and certificate to the server, and the server sends a value 1 after successfully processing the key exchange message. Next is alert protocol. It is used to inform SSL related alerts to the communication parties. These messages are encrypted and compressed There are 2 bytes in each message in the alert protocol. The first byte indicates the severity of a message. If its value is 1, then it is a warning, and if it is 2, then it is a fatal, which terminate the connection immediately. Right? So the second byte of the message contains preset error codes. So error code may occur during an SSL communication session. Next is handshake protocol. This protocol is used to establish a session between the server and the client. It provides information about the key and cryptographic algorithm to SSL record protocol. So here the server and client optionally authenticate each other using this protocol. This protocol allows the server and client to negotiate for various encryption algorithms and share the secret key for encryption. Yeah, so this was the end of the session of web security. Thank you.